Topic 1, Planet Earth. Part 2, longitude and latitude, or lines of longitude and latitude. And let's start with latitude. So latitude over here. And essentially latitude describes how far north or south a position on the Earth is from the equator. How far north or south of equator. So if I was to draw on my equator here, on my planet Earth, so a line through the centre, well, the equator to start with would have a latitude of 0 or 0 degrees. That makes sense because it's not north or south of the equator. That's 0 degrees. What I can then do is think about, well, what about the pole here at the top, the North Pole? That would have a latitude of 90 degrees north, or plus 90. And at the South Pole, we'll be at 90 degrees south. And what we can do, we can mark off places in between. And the way we can do that is we can use our compass, or sorry, our protractor, and we can think about, well, here would be 20 degrees. So I'm measuring off my protractor to 20 degrees, and I'll go to 20 degrees on this side. And anything on this level here would have a latitude of plus 20 degrees because it's above, or 20 degrees north. Let's mark on something else up here. Let's go with 60 degrees as well. So following my protractor around, 60 degrees here and 60 degrees here. You can draw another line of latitude on. This would be 60 degrees north. And we can do the same heading down below the equator, so 20 degrees, 20 degrees. I'm going to mark 60 degrees and 60 degrees straight away. So here, below the equator, it can either be minus 20 or 20 degrees south, and here, 60 degrees south. One thing to note, these lines are parallel, and so sometimes these lines are referred to as parallels. So you would have lines all the way across every degree, and you could break it down even further into arc minutes and seconds. But if you're working out where somewhere is, how far north or south it is, so perhaps the UK we can position about here, we can measure and work out, well, what line of latitude would go through it. So sometimes these lines are called parallels. You can see why they're all parallel to each other. And that's latitude. Now longitude is similar for east or west, but we have a problem with longitude. With latitude, we had the equator, and we knew everything could be measured from the equator. With longitude, there's no sort of set, is it straight down from there to there, or as the Earth turns, would it be down from there a bit further east or west? There's no set starting point, okay? So we would say it's how far east or west a position is from, and we had to make up a point almost. And what we've gone for is a line going through Greenwich, and we've called it the prime meridian. Now these lines that we're going to draw for latitude are called meridians. So prime meridian means the first meridian. So from prime meridian. And if I do a very quick sketch of the globe on here. So let's have the UK over here. And where we got, so Europe, Africa down here. Forgive my drawing, it's not perfect here. And we've got the Americas over here just coming onto view perhaps. And so on. If we've got the UK here, there's the South Pole, North Pole. We've said our prime meridian is a line that goes down through there. But these lines, they don't go straight down from a line straight down like so. They start at the North Pole and they end at the South Pole. So I've got to actually draw a bit of an arc going through Greenwich in London. And finishing down at the South Pole. So that there would be my prime meridian. I'll just focus that a little clearer there for you. My prime meridian, I'll label that there, which goes through Greenwich. Let's make a note of that. That goes through Greenwich in London. And then we can then draw on lots of other lines, or meridian lines. I'm going to do those blue so it becomes a bit clearer. So again, if I was 10 degrees east, there could be a line roughly here, say. This would be another meridian line. And if I was further east again, there's another meridian line to represent that. Remember, each time they start at the North Pole, end at the South Pole. And we can do the same going round this way. So let's just think this through. There must be one that goes almost straight down as we're looking at it, but this one would be like so. And let's draw a line like so. These lines are what we call meridians. And again, maybe on a map they might show every 10 degrees, or they might show finer than that, but actually we can measure to the nearest degree, then arc minute, then arc second. So it's how far east or how far west the position is. So let's just pick some place at random. If I was looking at a place over here, I would see that it is a number of degrees west. So let me think, how far west might that be? East, how far east that would be. That's probably about 50 degrees east. So that might be marked as 50 degrees east. If I was a position over here, this position is west of the prime meridian, so that might be marked as about 15 degrees west perhaps. And you can picture, actually, we can keep going east until we come back to here, or we can keep going west until we come all the way back round. So we only really go up to 180, because that'd be at the opposite side of the planet to the prime meridian. And actually that's 180 degrees east or west, so opposite prime meridian, at 180 degrees east or 180 degrees west is what we call the international date line. The first point where the new day begins, directly behind or opposite Greenwich and the Earth. So those are our lines of longitude, which we would call meridians. So these lines are meridians and they run North Pole to South Pole. Note that these aren't parallel, like our lines for latitude are parallel. And then finally, just to go into a tiny bit more detail on this, what we need to be able to understand is any position on Earth can be given some references. So New York, for example, may have the reference of 40 degrees, 42 arc minutes, and 46 seconds. And at the moment, I don't know how far, if that's north or south, so I need to mark on north. And then that tells me how far north or south it is. And I can break it down further. 70 degrees, 0 minutes, 22 seconds. And again, I don't know if that's east or west of the prime meridian until I label it. So I may need to make sure I label it, and that's west. And arc minutes and arc seconds are just 1/60th of a degree. So it helps us break this down into a more accurate picture or a more accurate description of where we are. So 60 minutes in a degree and 60 seconds, 60 seconds in a minute. So we can break it down to a very small slice of the Earth there.